With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi everyone, let's take a question. So here the question is that the beryllium. This question is paragraph based question. So here it is given that the beryllium shows different properties from rest of the alkaline earth metals. Why? Because of small atomic and ionic size, high electronegativity and high polarizing power. But it shows the similarities in properties to the second member of the next group, that is the aluminium. Why? Because of similar atomic and ionic size and nearly same polarizing power. It means here in the paragraph it is given that it shows the anomalous behavior with all other members of the group 2 because beryllium belongs to group 2, but it shows the resemblance with the aluminium. Okay, and aluminium aluminium. Okay, so now here our question is which amongst the following is soluble in water. Okay, so here we have the four options. Here we have the four options. The first one is BeSO4. The first is BeSO4. If we talk about the beryllium sulfate, if we talk about the beryllium sulfate, that is BeSO4. So here we have to discuss that how, which will be, whether it will be soluble in water or not, right? So here if we talk about the solubility of the sulfates, so here if we talk about group 2 elements, so we have BeSO4, MgSO4, we have CaSO4, SrSO4 and BaSO4. Okay, so in case of the group 2 elements, as we move down the group, okay, as we move down the group, so what happens is the solubility of the sulfates decreases. Solubility decreases. Now the question arises why it decreases. Okay, now the question arises why it decreases. Okay, so the reason behind this is the lattice enthalpy. Okay, reason behind this is the hydration energy, or we can say the hydration enthalpy, because in the case of the sulfates, otherwise the main reason which affects is the lattice enthalpy, but here the reason which affects is the hydration enthalpy. Okay, if we talk about the hydration enthalpy, so that is the enthalpy change that takes place when the 1 mole of anhydrous salt, okay, combines with the required number of water molecules. It means that when we have the formation of the hydrated salt, okay, when we have the formation of hydrated salt, like if we have MgCl2, this is salt, it exists in the form of MgCl2 dot 6H2O. Okay, for the alkaline earth metals, these are our alkaline earth metals, the hydration enthalpy order is Be2 plus, we have Mg2 plus, then we have Ca2 plus, strontium 2 plus and the barium 2 plus. Okay, hydration enthalpies of the alkaline earth metal decreases as we move down the group. Why? Because the size of ion increases. Okay, because the size of ion is increasing. Okay, so in this case beryllium sulfate is the soluble in water because the lattice enthalpy. Okay, now if we talk about the lattice enthalpy is the energy required, that is to dissociate 1 mole of ionic compound to the gaseous state. Okay, to the gaseous state. So here what we have is now the lattice enthalpy remains constant. Okay, in the case of sulfates it remains constant. Why it remains constant? Because the sulfate ion SO4 2 minus is large. Okay, it is big in size, it is large in size. Okay, but we have the cations, that is our beryllium to barium. Okay, and there we have the small increase in the size of cations. Okay, so that doesn't make any difference. Okay, here that doesn't make any difference, but we have already discussed that the hydration enthalpy order decreases as we move down the group. Okay, so due to the decreasing hydration enthalpies, there is the high solubility of the beryllium sulfate. Okay, there is the high solubility of the beryllium sulfate because of the smaller size. Okay, so we have the two factors that depend, we consider, that is hydration and lattice enthalpy. Here in case of sulfates, we consider the hydration enthalpy. Why? Because the lattice enthalpy remains constant as the size doesn't makes any difference, because there is a small increase in size, okay, in case of cations, but SO4 2 minus is too large in size. So we can say BeSO4 is soluble in water. Okay, now if we talk about the beryllium oxide, if we talk about the beryllium oxide, and now we know that the beryllium, okay, beryllium is small in size. We know beryllium is the first element of the group 2 and it has the small size, it has the small size. Okay, so that's why here it doesn't forms the ionic compound. Ionic compounds are formed by the transfer of electrons, but it forms the electrons by sharing of, it forms the compound by sharing of electron, that is the covalent sharing. Okay, it forms the compound by the sharing of electrons. Why sharing? Because it is very small in size, it is very small in size. Okay, so due to that reason only, this BeO compound, we have the, it will form BeO also by covalent nature. Okay, so this is insoluble. Due to the covalent nature, it is insoluble in water. Okay, it is insoluble in the water. So it means that here this is incorrect. Now, if we talk about the beryllium hydroxide, if we talk about the beryllium hydroxide, and if we talk about their sequence, so we have BeOH2, we have MgOH2. Like this, we have the all other members of the group, right? That is CaOH2. Here we have strontium OH2, and then we have the barium OH2. Okay, so as we move down the group, as we move down the group, the solubility increases. In this case, the solubility increases. Why it is increasing? Because the basic character, first reason is that basic character is increasing. Okay, and here what happens is the hydration energy. Okay, here in this case, lattice enthalpy and hydration enthalpy both are decreasing. Both are decreasing. Why they are decreasing? Because the size of cation increases, but the lattice enthalpy decreases more rapidly. Okay, here if we discuss, here basic character is increasing. Basic character is increasing due to the low ionization enthalpy. Low ionization enthalpy. Why we have the low ionization enthalpy? Okay, the low ionization enthalpy is due to the strong tendency to lose the electrons. Why they have the strong tendency to lose the electrons? Because of their small size, small nuclear charge, sorry, small nuclear charge. Okay, here in case of ionization enthalpy, what happens is there is the increase in atomic size, increase in atomic size. Why? Because of the addition of new shells. Okay, because of the addition of the new shells. Okay, and due to that what happens is the screening effect of the electrons in the inner shell, okay, will overweigh, will dominate the effect of increased nuclear charge. Okay, now we are discussing about the hydroxides, we are discussing about the hydroxide. Okay, so here the hydroxides are less basic. Okay, here if we compare with the alkali metals, but that's not needed. We want to know just that which will be the more whether the beryllium hydroxide will be soluble or not. Okay, so here the reason is the solubility increases with increase in atomic number. It increases with increase in the atomic number. Why it increases? Because lattice enthalpy, lattice enthalpy and hydration enthalpy, we have already discussed what are these. Okay, hydration enthalpy decreases down the group. Okay, it decreases. Why it decreases? Because the size of cation is increasing, size of cation is increasing down the group. Okay, but what happens is the lattice enthalpy decreases more rapidly. Okay, lattice enthalpy decreases more rapidly. It means that factor is the dominating factor here. Okay, that decreases more rapidly, okay, than the hydration. So that's why solubility is increasing. solubility is increasing. Okay, that's why the solubility is increasing. Okay, so it means that here beryllium hydroxide is also insoluble. Now if we talk about the beryllium chloride, so it has the reason that the beryllium chloride is covalent compound. It is covalent compound. Okay, so that's why it is soluble in the organic solvents due to the covalent nature. We have already discussed that why it has the covalent nature, because it forms the compounds by the sharing of electrons. Okay, so that's why, okay, it shows the hydrolysis with the organic solvents. Okay, it undergoes the hydrolysis, but it is insoluble in water. It is insoluble in water. It is soluble in the organic solvent. So here our answer is BeSO4. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.